now have a series question. So the first term of a geometric series is 14, and the sixth term is 448. Calculate the value of the constant ratio R. So we know that in series, the first term, which they say here is 14, we normally represent that by A. So that means in our case there, so this is for 2.1.1. So A, which is the first term, is 14. And then we also know that T6, the sixth term, is 448. We know that the general term of a geometric series is Tn is equal to A r to the power of n minus 1. So here we're talking about T6, which should be equal to A r to the power 6 minus 1, which is A r to the power 5. So we know that T6 is 448. So that means A r to the power 5 is equal to 448. And we know what A is. A is given as 14. So that means that I can write 14 r to the power 5 is equal to 448. So my task here is to find the common ratio R. This common ratio R. So what I'm gonna do then is I would divide both sides by 14. Divide both sides by 14. So that cancels out. So that leaves me with R to the power, not 2, sorry. Let's get rid of that. That should give me R to the power of 5 is equal to 448 divided by 14 should give me 32. Now, in order for me to find R, there are a couple of things I could do. Either I could raise both sides to the power of 1 over 5, or I could take fifth root of both sides. So I'm going to go with the latter, which is take fifth root of both sides, because this is power 5, so I have to take fifth root of both sides, like so. Okay. So fifth root of R to the power 5 is R. Alright, so, and then the fifth root of 32 is 2. So that would be my final answer for this first question. So I'm just gonna erase this and make way for the next question. For 2.1.2, it says determine the number of consecutive terms that must be added to the first 6 terms of the series in order to obtain a sum of this 114,674. So let's really understand what they mean here. So we want the number of consecutive terms. Consecutive terms is like terms that follow each other without skipping any terms. So from term 1, the first term, to a certain term. So if we were to sum up a certain number of terms, let's say, to really understand this, we could say, let's say term number 1 plus term number 2 plus on and on and on until we get to term number 6 plus more terms until finally we get to term number n. We don't know what term number n is, but if you were to add all these terms, you would get a sum of 114,674. Okay, so we want to see how many more terms do you need to add to the first 6 terms. So if I like sum up the first 6 terms from T1 and up to T6, how many more terms would I need to add? So that means from T7 until Tn, right? How many more terms do I need to add on top of the sum of T1 up to T6 in order to make my total sum to be 114,674. So in other words, I can just find how many terms add up to 114,674. Once I find how many terms add up to this, then I subtract 6 terms to see how many terms were after term number 6 that I needed to add. So let's see what we mean by this. So I know that for a geometric series, sum to n terms is equal to a by r to the power n minus 1 all over r minus 1. So that's my formula for sum to n terms. I'm saying, so the sum to a certain number of terms n, right, from T1 up to Tn, is giving me, according to the question here, it should give me 114,674. So I want to find what is the value of n, which would give me this, right? I know what a is. We know that a is 14. That's the first term. We know that r, we calculated r in the first question. We found r to be 2. So then we're going to need to substitute things and then find what n is. So a is 14, and then r is 2, so 2 to the power of n minus 1 over 2 minus 1 should give me 114,674. And then so simplifying things here, I would have 14 by 2 to the power of n minus 1 over essentially over 1 is equal to 114,674. So I can just basically, I don't need to have this over 1 thing, so I can just divide both sides by 14 because I want to open up so that I can find this n here. So if I divide both sides by 14, then this 14 and this 14 would cancel out like that. Then I would have 2 to the power of n minus 1 is equal to, if I divide, let's see, let's punch our calculators to divide 114,674 divided by 14. It would give me 8191. It would give me 8191. And then so I take this -1 to the other side because I just want to remain with 2 to the power of n on this side. 2 to the power of n is equal to 8191 plus 1. So that would be 2 to the power of n is equal to 8192. So then we know that if the unknown, like in this case, the unknown is n, which we want to find, it's an exponent, it's on the power. For us to solve that, we need then to use logarithms. So we introduce logarithm on both sides. So I'm just going to introduce log 2 to the power of n is equal to log 8192. So then what that does is, when the n drops behind the logarithm, so it becomes n log of 2 is equal to log of 8192. Just gonna make some space up here. Hope that will not be confusing. So I'll leave that bottom so that we can follow the continuity. Then we have here, so let me just write n log 2 is equal to log 8192. So then to find n, I would divide both sides by log 2. Log 2, then log 2 cancels out there. So I would remain with n is equal to, then we punch our calculators to see what is log 8192. Log 8192 divided by log 2. It gives me 13. Right, so it gives me 13 straight. So what this means, well, let's interpret this 13. It means if I were to add up from T1 plus T2 plus up to, again, let's say T6, and I continue adding T7 plus all the way up to T13. If I add up all these 13 terms, the first 13 terms in my geometric series here, the sum that I would get, if I add them all up, it would be this 114,674. So the question was, let's remind ourselves about the question. The question was, determine the number of consecutive terms that must be added to the first 6 terms of the series in order to obtain a sum of. So if you were to isolate or remove the first 6 terms, how many more terms do you need to add to the first 6 terms in order to get this sum? So basically, I know the total number of terms that I add up to get this sum is 13. So in order to answer this question, then I need to say 13 terms minus 6 terms, the first 6 terms. Then that should give me 7. So that is the final answer. The final answer is 7. Then moving on to 2.1.3, I'm just going to make space for that. So 2.1.3 says if the sum of the first, if the sum of another series is 448, if the first term of another series is 448, so 2.1.3 to so 2.1.3 says that if the first term of another series is 448, so A, which is the first term, is 448 in this case, and the sixth term, So T6 is 14 in this case. Calculate the sum to infinity of the new series. So they want sum to infinity. Sum to infinity, we know the formula for sum to infinity, which you can find at the back of your question paper. It will be a over 1 minus r. So in this case we do have a, that's 448, but we don't know what r is. So maybe to start we could find what r is in this particular case using this T6. We know that T6 is a r to the power of 5, so that's 14 in this case. Yeah, so then we know that a is 448, so 448 r to the power 5 is equal to 14. So to find r, then I would need to divide both sides by 448. So r to the power 5 is equal to 1 over 32. And then remember, if I want to find r and it's r to the power 5, I have to take the fifth root of both sides, or I raise both sides to the power fifth, 1 over 5. But either way you get the same thing. So the fifth root of r to the power 5 is r, equal to the fifth root of 1 over 32. It is the fifth root of 1 over the fifth root of 32. If you recall, the fifth root of 32 is 2, and the fifth root of 1 is 1. So r is equal to 1 over 2. So we know that our r is 1 over 2, or half. So then we come back to our working here. Sum to infinity is equal to a is 448 over 1 minus half. That is 448 divided by half. You could punch that in the calculator. You should find 896. That would be the sum to infinity of this series. All right.